Hello students. Now discuss the problem which is based on the properties of the determinant. Now let's take the first example is evaluate 219, 117, 345, 19, 9, 34, 7, 3 and 5. Now the solution. Now this question we can solve directly by the expanding of the determinant. But the expansion of the determinant is very complicated. Now the number is very large. So before by applying the some properties of the determinant, we can simplify this determinant. Now so first of all, if the R1 is changes, now if the R now, if the R1 is changes with the R1 minus 11 times of the R2 and the R2 is changes the R2 minus 3 times of R1. So, after applying this operation, so we get 10, 18, minus 29, minus 2, 0, 19, 7, 3, 5. Now the third row is as it is because we don't apply any operation for the third row. So the third row is the as it is. Now again apply the next operation is R1 is changes with the R1 minus 6 times of R3. So we get the minus 32, 0, minus 59, minus 2, 0, 19. Now the 7, 3, 5 is as it is. Now the second row and the third row is as it is. Now because we have applied the operation in R3. So why we are doing this? We are doing all this because if we can simplify in the very easy form, then the sum of the elements should be terminated. So we don't need to solve. So in this question, let's see that this two elements are 0. So if we expand the determinant along this column, then these two are 0. So we need the only one expansion. So we can very easily simplify. So let's see along this. First of all, along this column, along the column, the element of the first column is 0, the 0, then it's plus, minus, plus. So minus, plus, minus. So take the minus sign 3 times and the determinant is 32, 2, minus 59 and 99. 19, sorry 19, minus 32, minus 59, minus 2 and 19. So we can simplify minus 3 minus 32 into 19 minus 2 minus of 2 into 59. So minus 3 minus 608 minus 118. Now the result is 2178. Second, show that 1a square, 1b square, 1c square, a minus b minus c minus a. So similarly we can simplify the directly, but now here the elements are in first column is 1, 1 or 1. So by using this we can terminate. So apply the operation in first row is R1 is changes with the R1 minus R2 and the R2 is changes with the R2 minus R3. So apply the operation in determinant. So R1 minus R2, 1 minus 1 is 0, A minus B is A minus B, A square minus B square. Now in the second row, R2 minus R3, 1 minus 0, 0, B minus C, B square minus C square. Now the third row is as it is, 1C, C square. Now these two elements are 0, so we can expand along this column. It is plus minus plus. So for the 1, now the determinant is A minus B, A square minus B square, B minus C, B square minus. So now in the first row we can take the A minus B is common. 1 is, and it is A plus B, B minus C, B square minus C square. Now in the second row, same the B minus C we can take the common. A minus B, B minus C, 1, A plus B, 1, B plus C. Now simplify by this, A minus B into B minus C, B plus C minus A plus B. B to B cancel. Now this A minus B, B minus C, C minus A. Now the next example, determinant one A, 1 A, A cube, 1 B, B cube, 1 C, C cube is equal to A minus B, B minus C, C minus A into A plus B plus C. For the solution, now apply the operation in second and third row. So now the R2 is changes with R2 minus R1 and the R3 is changes R3 minus R1. So the first row is as it is, 1 A cube, R2 is changes R2 minus R1, 1 minus 1, 0, B minus A, B cube minus A cube, 1 minus 1, 0, C minus A, C cube minus A cube. Then in second row, common is B minus A, and third row common is C minus B minus A, C minus A. First row is as it is, 1 A cube, 0, 1. Now the expansion of the B cube minus A cube is B minus A, B square plus AB plus A square. So remaining is B square plus BA plus A square. Now in the similarly it's a 0, 1, the C square plus CA plus A square. Now expansion of the determinant along this element, along this row. So B minus A, C minus A, 1 is multiply with 1, B square plus BA plus A square, 1 C square plus CA plus A square. B minus A, C minus A, Now simplify this determinant is now c square plus ca plus a square minus b square plus ba plus a square. B minus a.
Excuse me, sir. Said that pen drive will take next period.
B minus a. C minus a. C square minus B square and the CA minus BA. A is take it common. Now it is C minus A. Now the B minus A, C minus A. Now the C square minus B square is the C minus B into C plus B and the C minus A. So we can take the common C minus B. So we can take the common C minus B. Now the remaining is C plus B plus A. Now the next example, if A, B, C are in AP, show that x plus 1, x plus 2, x plus A, x plus 2, x plus 3, x plus B, x plus 3, x plus 4, x plus C is equal to 0. Now if the in question is given the ABC are in AP, if they are in AP means ABC are in AP. So B minus A equals to C minus B. So B equals to A plus C upon 2. Now that is common difference. Now simplify this determinant again by using the properties. Now in the third row, apply the operation is R3 is changes to R3 minus R2, and in the second row R2 is changes with the R2 minus R1. Now the first row is as it is, x plus 1, x plus 2, x plus A, and the R3 minus R2. So x plus 3 minus x plus 2 is 1, 1, and the x plus b minus x minus x plus b minus x plus a is the b minus a. Similar in the third row, 1, 1, c minus b. Now the b minus a and c minus b are the common differences. So x plus 1, x plus 2, x plus a, 1, 1, d, 1, 1, d. Now if the two rows are identical, then the solution of the determinant is 0. So it is equals to 0. Now hence proof.